At Greenbushes, Talison Lithium mines and produces over a third of global lithium production. The area was still explored for tin and then and still is for tantalum. By dint of digging, a huge vein of spodumene was discovered on the rock. There, the pegmatite rock often contains up to 50% spodumene. This ore, a silicate of lithium and aluminium that is easily identified because it shines in the sun, is the chemical industry's basis for all derivatives of lithium. The extraction procedure is a conventional process. The holes are dug by drilling and explosives are inserted. It then remains to carry fragmented rock to the crushers in the factory. After an initial coarse crushing, the ore is transported by a conveyor belt to a finer grinding in a mill with steel balls until the ore is smaller than 1/10 of a millimeter. Water is added to the mill, which allows a slurry of fine particles called the pulp to be obtained. This is followed by a physical separation of the rock and the spodumene by density difference in a flotation tank. Collectors, which are usually surfactants, for example oleic acid, are added to the pulp. They will make the lithium minerals hydrophobic by activating the surface. The pH is adjusted to be slightly basic, between 8 and 10 approximately. Foaming agents, typically alcohols, are added, which will decrease the surface tension of the pulp. This will prevent coalescence of the bubbles and thus make the foam compact and stable to make the process more efficient. The foam which floats is collected at the top of the flotation tank, while the remaining pulp is fed into the next tank for a second pass in order to recover the maximum lithium ore. This is done in multiple passes through the flotation tanks until there is no more lithium ore in the pulp. The recovered foam therefore contains a high concentration of spodumene. If there is iron ore, they use a magnetic separation to remove it. This mixture is then passed through a filter mat, which will allow liquid to flow and thus will dry the spodumene. The final product, depending on the desired quality, contains between 63 and 94% spodumene, the impurities of which are silica with a little feldspar. It remains only to pack and send it around the world, mainly to China, to convert spodumene into various lithium derivatives.
The extraction of lithium consists of the following major steps: size reduction and granulation, calcination, water leaching, evaporation and crystallization, and lithium recovery. The lithium ore from the mine is fed directly to the processing plant, or alternatively to a pad that can store 30 days of production. The ore is crushed and milled to approximately 150 microns. Anhydrite and dolomite reagents required in the next step of the process are separately milled to the same size. They are then mixed with the ore in a specialty granulator to form granules. The granules are dried with hot gases on their way to the calciner. At around 1000 degrees centigrade, lithium, sodium, and potassium, the alkali metals in the ore, are converted to water-soluble sulfates. The resulting calcine is then air-cooled in a fluidized bed cooler. Preheated air from the cooler is added to the calciner, while the calciner off gas is used to produce steam for the downstream evaporation and drying units. Lithium, potassium, and sodium are dissolved, along with trace amounts of magnesium and calcium. Other impurities remain insoluble. The leach solution is cycled to maximize lithium concentration. Studies indicate recovery rates of 90% for lithium and 80% for potassium. In the evaporation and crystallization phase, clarified leach solution is mixed with recycled solutions and fed to the evaporators, where lithium sulfate is further concentrated and glycerite is crystallized by cooling. After solids and liquids are separated, the liquids are pumped to the lithium recovery circuit, while glycerite is further decomposed with water, resulting in crystallized potassium sulfate. The potassium sulfate is then separated, dried, and packaged as a marketable product. The liquid solution from the decomposition circuit is recycled back to the evaporators. In the lithium recovery circuit, trace calcium and magnesium are removed from the concentrate using precipitation and resin technologies. Lithium carbonate is precipitated by adding sodium carbonate. Once filtered, a lithium-barren solution crystallizes glauber salt, which can be converted and sold as an anhydrous sodium sulfate byproduct. The lithium carbonate is then washed thoroughly with hot water and dried. High-quality lithium carbonate is now ready to be packaged in 25-kilogram bags and stored on pallets in preparation for international shipment for use in the rapidly expanding battery market.